Hi, Year 5. We've been exploring multiplication, and at the moment we're looking at how we can visually represent our learning. The purpose of that is that by engaging in math visually, it allows our brain to communicate in two areas, visually and symbolic. By doing this, our understanding of the math concepts such as multiplication is strengthened, and they tend to help you to be able to perform better. We're going to explore a few other ways of how we can visually represent our learning. Last week we looked at the area model where with a two-digit number we were able to separate the two-digit number into the tens column and the units column, and then we were able to work in each of these areas separately to find our answer. So by doing 10 times 5 equals 50, 8 times 5 equals 40, and then 40 plus 50 equals 90. I want you to think about how might you visually solve the problem 18 times 5. Take some time to think about that, and then we're going to share some examples with you. You should have explored some of your own ways of how you might visually represent the multiplication problem 18 times 5. What I'm going to do now is just show you some different ways that others have chosen to visually represent their learning. So you can see Neil here, who is a student. For the number 18, he has split 18 into two groups. So he's looked at doubles. So he knows 9 plus 9 equals 18, and he has separated that. And then on the outside here, just like with the area model, he's multiplying by 5. So in here he's doing 9 times 5 equals 45, 9 times 5 equals 45. Then you add these two together and you will get 90. Ricardo has decided instead of dividing 18 by 2, he has decided that he's going to multiply the 5 by 2. So instead of doing 18 times 5 to work out his answer, he's done 9 times 10. So he's half the 18, but he's doubled the 5. So 9 times 10 equals 90. Just another way of being able to solve it, but visually representing it like this so that we can see that it is the 5 that he has doubled to get his answer. Then we move to Jamie. Jamie's decided that to solve his problem visually, he has rounded 18 up to 20. So here we can see that 18 plus the 2 is 20, and he's worked out 20 times 5 equals 100. Now he knows that 18 plus 2 equals 20, so he needs to work out here what it is that he needs to take away from the 20. So 5 times 2 equals 10. So he's taking that away from the total of 100 because he only needs to work out 18. So then he comes down here and he has 100 take away 10 equals 90. Ariane has decided that she is looking at splitting 18 into numbers that she feels comfortable with multiplying by. So 15 and 3, because 15 plus 3 equals 18, and then she's multiplying by 5 again over here. So she first does 15 times 5 is 75, 5 times 3 is 15, add 75 and 15 together and we get our answer. Brian, on the other hand, has decided that he's going to separate the 5 into groups that are easier for him to work with. So he has split the 5 into group of 2, 2 and 1. because that equals up to 5. So he's done 2 times 18 is 36, 2 times 18 is 36, and then 1 times 18 is 18. He's added those three numbers together. 36 plus 36 plus 18 equals 90. So you can see there are many different ways of how you can visually represent a number when you're solving it. We'd like you now to try and use some different visual representations and symbols to see if you can solve this problem. 72 times 6. How many different ways can you visually represent this number?